Hiya folks, so if you're watching this video it means we probably didn't get time to finish the second example in the Astigmatic Pencil lecture. So we're going to run through an example of an astigmatic pencil question when we have a near object. So our point object is now 80 centimeters in front of the lens from example 1. And that example was a plus 2 at 90. We're asked to calculate the new positions and lengths of the line images and their orientation, and then find the position and diameter of our disc of least confusion. So the prescription that we had to start from example 1, and you have to pardon the fact that I'm cack-handed and covering everything that I'm writing up, was a plus 2 ds, plus 2 dc, axis of 90. Now we want to work in a cross-sill form. So that means in cross-sill we've got plus 2 dc axis 180 and a plus 4 dc axis 90. Because I don't need that sphere sill form, I'm going to cross through it so I don't take numbers out of it by mistake. When we're working with astigmatic pencil, we need to assign F1 and F2 to our powers. And F1 is always going to be the strongest power, and F2 the weakest. So I'm going to use blue for everything to do with F1, I'm going to use red for everything to do with F2. Now at this, I'm going to put my diagram together. And I'm going to use quite a lot of page for this. You don't have to, by all means. So it starts with our axis, and over on the left of our axis I'm going to draw my lens, and I'm not going to draw it huge because I don't want a massive diagram. I know that F1 of my lens is plus 4 dc axis 90, and I know that F2 of my lens is a plus 2 dc axis 180. Now remember, for astigmatic pencil we want to work in cross-sill form and keep our axes. We don't want to do powers along. Powers along is for prisms. From the question we know we have an object at a distance of 80 centimeters. Little l is minus 80 centimeters because it's measured to the left. And we're going to have light diverging out and hitting the front surface of our lens. Now, F1 is the stronger power. Strong power, short focal length. It's going to bring light to a focus at an arbitrary point relatively close to the lens itself. So I'm going to call the distance from the lens to its focus little l1 dashed. And that focal point is important. We know that light doesn't just stop when it hits a focus, it will carry on, it will pass through, and it will keep diverging from that point. Our second power, F2, is weaker, so it's going to focus to a point further away. And again, at that arbitrary distance, because we're not drawing this to scale, I'm going to say that is little l2 dashed. That is the image distance for the second focus. I think I've got a little bit far with the arrow, but that's not the end of the world. Where the red light focuses is where we're going to find h2 dashed, the second line image, which will always be the biggest image. Where the blue light focuses, we're going to find h1 dashed. So these are our line images. Okay, you don't have to do them as arrows, you can just do them as straight lines. Now the other feature that you find in the astigmatic pencil is something called the disc or the circle of least confusion. So I'm going to use green so we can see that hopefully a little bit easily. And that will be found where the astigmatic pencil is at its smallest cross section. The The distance is little lc dashed, and we call the circle of least confusion hc dashed. That is the diagram that you need for 90% of astigmatic pencil questions, and this is the diagram that we're going to keep coming back and referring to as we run through the maths. What we're going to do in a moment is we're going to ray trace from our object through F1 to find the position of L1 dashed. Then we're going to ray trace again from our object through F2 to find the position of H2 dashed. We can then look at finding the sizes of H1 dashed and H2 dashed, either using ratios between vergences or by using any set, and we have got a few sets, of similar triangles that exist in this diagram. Once we've got all the details for those line images, where they are, how big they are, and what their orientation is, we're going to look at our circle, our disk of least confusion, and we're going to find its position and we're going to find its diameter. So that is the plan moving forward from here. Okay guys, so we have our prescription, we have our diagram, and I'm going to keep this diagram over on this right hand side whilst I'm doing the maths over here on the left. So what we're going to do is we are going to start by finding little L1 dashed and little L2 dashed. So first thing we're going to look for is little L1 dashed. And you'll notice that I'm using blue here because what I'm particularly interested in is relating to F1 and the blue light. So we know that our object little l is at minus 80 centimeters in front of our lens. From that we can work out big L, the vergence of light hitting the front. And we do that by doing n times 100 because we're working in centimeters here, and then we're going to divide that by little l. N is 1 because we're in air, times 100 divided by minus 80. So let's grab a calculator and see what that comes out as. So 1 times 100 divided by minus 80, minus 5 over 4, and if we convert that to a decimal, minus 1.25 diopters. So any light that's hitting the front surface of our lens at the moment is diverging by minus 125. F1, in our example, is plus 4. And that's going to converge that light. So we can work out what happens to the light leaving by using the normal vergence equation. L1 dashed is equal to L1 plus F1. L1 is just L, big L. There is no 1 or 2 here. We don't have two objects. There is just the 1. So, minus 125 plus plus 4 is going to give us a grand total of plus 275. When light leaves this lens, it's converging by 2.75 diopters, but what I want to know is where is that coming to a focus. So I'm going to do n dashed times 100 if I want to stay in centimeters, divided by big L1 dashed. This is just like normal ray tracing. N dash is 1 because we're in air, times 100 divided by my plus 2.75. So that's not something I'm going to do in my head. 1 times 100, so it's 100, divided by plus 2.75. It is focusing at a little L1 dashed of plus, because remember sign convention is important, 36 point, and those dots across the top mean that there's recurring figures. So 36.36 recurring. Now if I'm rounding that to 2, 36.36 centimeters. That's little L1 dashed. Next thing we're going to find is little L2 dashed. Swapping colours because I'm looking at a different thing now. Now, my object hasn't moved, which means my big L remains the same. So I'm going to start my ray trace at my big L of minus 125 ds. Object hasn't moved. divergence stays the same. But my power in the other meridian, the other side of this, meridian of this astigmatic lens isn't a +4, it's a +2. It's a little bit weaker, so it's going to focus the light further away. I want to know what it's doing, and that's L2 plus M25 plus a +2. My L2 dashed is going to be +075. And from there, we're going to go back to little L2 dashed. Again, that's N dashed, times that by 100 over my big L2 dashed. N dashed is still 1, times that by 100 over my plus 0.75. 1 times 100 over my plus 0.75 is 133 point lots of recurring 3s. So what I have found so far are the positions of my line images. And what we're going to do now is we're going to use the similar triangles. We're going to use the formulae that you have in your assignment sheets, not your assignment sheets, sorry, your lecture sheets, and we're going to find the sizes of these images. So if I wanted to find H1 dashed, the size of our first line image. Okay. H1 dashed from your lecture sheets is little L2 dashed minus little L1 dashed, all divided by little L2 dashed times by D. Now in the formula, there isn't the distance between lenses, it isn't the distance between the focal lines. D is the diameter of the lens. Now we might remember that from our previous question, the diameter of our lens was 50 mil. In that case, that will be 5 centimeters. Because what I want to do really is keep everything as much as possible in the same unit. So, my little L2 dashed was 133.33 minus my little L1 dashed of 36.36, all divided by my L2 dashed of 133.33 times by my diameter, and remember these are all in centimeters, so my diameter is 5 centimeters. So all of that happens, and we times it by 5. So let's grab a calculator across. Plus 133.33 minus 36.36, all divided by my plus 133.33 times by 5. So that tells me that this line image is 3.64 if I'm rounding it to 2 decimal places, centimeters. That's the size. And as for orientation, one of the big and important points of our astigmatic pencil, one of the reasons that we work in cross-sil, is we know that cylinders make a line image along their axis. So if we have an axis of 90, which is vertical, our image here from the first power will also be a vertical image. That's H1 dashed. Next thing we're going to find is H2 dashed. Size of the second line image. Okay, so when we're looking for H2 dashed, the formula is very, very similar. H2 dashed is equal to L2 dashed minus L1 dashed over L1 dashed times by D. So let's pop some numbers into there. Top doesn't change. it's plus 133.33 minus 36.36, all divided by now 36.36. That all happens, and we times it by 5. So plus 133.33 minus 36 over r plus 36.36, all times by 5. So we've got plus 13.33 centimetres here. That's what our maths comes out as. And remember, we have an axis of 180, an axis that's horizontal, which means that our line image is going to be horizontal. So that is the positions of the images. That is the size of the images. And what we're going to find now is we're going to look at the details of the disk of least confusion. We're going to find its position and we're going to find its size. All we're left to find now are the features of the disk of least confusion, the point where we are at our smallest cross-section along the astigmatic pencil and where it would create the clearest image if an eye was to view this structure of light. Now, we can't find LC dashed by using the relationships of little l2 dashed and little l1 dashed because we know that focal lengths aren't additive. However, what are additive are focal powers. And this disk of least confusion, whilst it's not halfway between these 2 points in terms of distance, it is in terms of its vergence, in terms of its power at that point. We say it is dioptrically midway between the two images. So if we want to find little LC dashed, to do this we first need big LC dashed. We need the vergence at that point. And to get that, we do big L1 dashed plus big L2 dashed, and then we divide it by 2. So our big L1 dashed was 2.75. Our big L2 dashed was plus 0.75. And then we do all of that divided by 2. So what's that? 350 at the top divided by 2 would give us plus 1.75 diopters. That is the vergence of light at that point. But I don't want the vergence of light at that point, I want the distance. So to get little LC dashed, I'm going to do n dashed because it's after refraction. I'm going to times that by 100, and I'm going to divide that by big LC dashed. So we know it's in air, so it's 1 times 100 divided by plus 1.75. 1 times our 100 over plus 1.75. And that gives us plus 57 point, and let's get rid of all those recurring values, 1.4 centimetres. That is the position of our disk of least confusion. Nice, quick and easy to find that. And the final part that we need to have all of the features that were asked for in this particular question is the size of the disk of least confusion. And again, you can do this by similar triangles, or you can do this by using the relationship between vergences. Because we used the similar triangles in the lecture, I'm going to use the similar triangles again here. So we're going to use the same formula from your lecture sheet. HC dashed is equal to little L2 dashed minus little LC dashed, all divided by little L2 dashed, and then again times by the diameter of the lens. So little L2 dashed, from memory was 103.3 minus little LC dash that we've just worked out is 57.14 centimetres, all divided by our plus 133.33. All of that happens, and then we times it by that 5 centimetre diameter of the lens. So let's pop that all in. So plus 133.33 minus our 57.14 over our plus 133.33, all of that times 5. And that tells us that it's 2.86 centimetres in diameter. So we have taken our lens into cross-sill form. We've seen what is f1, the strongest power, and f2, the weakest. We've created our diagram so we can see the features that we need to find. And then we've ray traced through and we've found the position and the size of our first line image. We've found the position and the size of our second line image. We then went and found the position and the size of our disc of least confusion. That is an astigmatic pencil question for a near object, and that is the lecture example all done. If you have any questions, folks, then by all means drop us an email, but that is the end of that. Thanks for watching.